Right, here we are, the last video of the school year. Oh my gosh, I think I'm starting to cry a little bit here. Anyways, so this video we are gonna be exploring the reciprocal trig functions. We touched these in the beginning of the unit and then didn't really come back to them. But I just wanted to show you guys that yes, reciprocal trig functions are in fact a big part of this trig stuff. So it's good that we know how to use them. Okay, so reciprocal trig functions. If you don't remember, I'll do a quick recap. Right, so we learned cosine, sine, and tangent of your angles. Cosine was adjacent over hypotenuse, or I guess now we can kind of use our new definition, right? Ooh, our new definition, which is the x value, right? It's going to be x. Sine is opposite over hypotenuse, or our new definition, y. And tangent is going to be TOA, which is opposite over adjacent. And our new definition was it's the y over the x value. That's not green. Why didn't that come out green? Let's try that again. Okay, it's green. And all right, that was weird. All right, so that's sine, cosine, and tangent. Well, if we know this, right? If we know this and we know the relationships between the reciprocal trig functions and our regular trig functions, well, we can come up with the new definitions, right, for our reciprocal trig functions. Watch. Cosine was related to secant. Okay, SEC, right? Secant of the angle, whatever it was. So we actually don't need to even make triangles for this again, right? Because we know cosine is x. Well, what is the reciprocal? I'll do this to help you out. It's over 1, right? What is the reciprocal of x over 1? I just have to flip it. So it becomes 1 over the x value. Oh, that's so easy, right? Yeah, that means, the fractions might be a little bit more complicated, but I mean, as long as you understand the idea, it won't be too bad. Sine, the reciprocal trig function of sine is cosecant, which means if I flip the y over 1, it becomes 1 over y. Oh, it did it again. All right, and then lastly, we have cotangent of theta. If the tangent of theta is y over x, that means the cotangent of theta is x over y. All right. So let's try one. Make sure you have your unit circles ready. You can use it as a reference. It's fine. But like I said, it's good to memorize those first quadrant values. I know in Mr. Ruck's class for pre-calc, you're going to have to memorize the whole chart. All right. So, let's try secant. Let's go easy. Secant of 30 degrees. Okay. Actually, you know what? Secant of pi over 6. Ooh, what the heck is that? Yeah, radians. You must know how to play with radians, okay? If you want to change them into degrees, you can, but I'm just saying, it's easier to play with them this way, okay? Secant of pi over 6, pi over 6 times 180 over pi. Pi's cancel out. You're left with, oh, it was 30 degrees. Oh, I'm such a trickster. All right, so at 30 degrees, if you look at your unit circle, right, at 30 degrees, that's this one, it is root 3 over 2, comma 1/2. And secant is the flipped version of cosine. So this means 1 over x. So in this case, it's going to be 1 over, well, my x value is root 3 over 2. So I just write root 3 over 2. Okay, we're going to do some keep change flip. That's a shout out to my period 5, right? And you get this, right? 1 times 2 over root 3, which is just 2 over root 3. Okay, if I wanted, and that's your answer, right? But if I wanted to take this an extra step, because I know a lot of books use this, I'm going to rationalize the denominator, meaning I'm going to get rid of the square root in the denominator. We did do this, but I don't know if you guys remember this. It becomes 2 root 3 over 3. And that is secant of pi over 6. Okay? So let's, I don't know, let's try another one. Let me do cotangent of, let's do a harder one. Cotangent of negative 630 degrees. Oh my gosh, what the what? Right? It's kind of sounds bad, right? But don't worry, it's not too bad. Just draw out the angle, all right? Just remind yourself what cotangent means and then like just, take it piece by piece, all right? This is the first time you guys are doing these, you're not going to get these like quickly in the beginning, right? So here we go. Well, negative 630. Well, we gotta see like, well, where is that on the coordinate plane, right? Negative means you go clockwise, and then we know, well, how many times does 360 go into 630, right? So if I just have my calculator here and I subtract 360 from it, I'm left with 270, right? So what does that mean? This is the same thing as negative 360 plus negative 270, right? So that means I go all the way around 360 degrees, and then I go another 270. So what is that? That's 90, negative 90, negative 180, negative 270, and that's where it ends, right? This is where we ended up, this point right here, right? And we like these values because they're easy. It's right on the, I was going to say right on the money, but it's right on the axis, right? So this point right here, this is 0, 1 on our unit circle. We like that. It's easy, right? So watch. Here we go. We have our point. We know where it is. Now we just have to break down, well, what's cotangent mean? Well, we said cotangent is the reciprocal of tangent. So you just flip tangent, meaning it's not y over x. It's going to be x over y. Let me see here. There's my x. There's my y. So if I take my x value, which is 0, divided by my y value, which is 1, you get 0. Because you can divide 0 by 1, right? It's just 0. All right? Not so bad, hopefully. I will do one more just for funsies, and this is going to be our last example. Cry, cry. All right, let's do cosecant, because I haven't done one of those yet. Cosecant of negative 31 pi over 6. Oh, geez, Mr. Lee, what the heck? That's crazy. Once again, you can change it into degrees, or you can keep it as radians. All right, it's totally up to you. I don't know what you guys like at this point, but I'm gonna show you the radians way because it's much easier to kind of like do it the radians way. All you need to know for the radians way is like, well, how far each axis is, right? So this is pi over 2, this is a pi, this is 3 pi over 2, and this is 2 pi. All right, so essentially you're trying to see how many pi's are in this thing, right? Like kind of like the last one, how many like 360s were in 630. We're trying to see how many like 2 pi's are in this thing. So all I have to do is just rewrite this thing, right? This becomes negative 30 pi over 6 plus negative pi over 6, right? Negative 1 pi over 6, right? Because that gets me negative 31 pi over 6. So this guy right here is negative pi over 6. Sorry, that came out really weird. Well, 30 divided by 6, I know that's 5, right? Right? 6, 12, 18, yeah, 5, right? So this becomes negative 5 pi plus negative pi over 6. So let's think here. If pi is 180 degrees and I have negative 5 of them, so negative, once again, means you're going in clockwise. So that's 1 pi. This is 2 pi, 3 pi, 4 pi, 5 pi. So I hit 5 pi, and this negative pi over 6 tells me I go negative pi over 6 more, which is right there. All right? Negative pi over 6 is actually, this is 30 degrees. If you don't believe me, just change it to a degree. And since we're in the second quadrant, the x value gets flipped, so this is negative root 3 over 2, comma 1/2. Whew, all right. And since we're talking about cosecant, so we have our point. So once you find the point, the rest of it should be pretty easy. You just got to remember what the trig values mean, right? So we have our cosecant here. Cosecant, if you don't remember, that's the one that's related to sine, right? Sine relates to cosecant. And sine was y. So cosecant is 1 over y. So this means take your y value, which is 1/2, and just flip it. So this becomes 2. That's it. You're done. Okay? This is enough work for this problem, all right? If you need to draw out the angle, you can. But I should see on your assignment work, under your assignment work, this type of stuff. Like I should be able to see like your thought process. If you just give me an answer, that tells me that you didn't show me enough work. All right, you need to show me something on these assignments, otherwise I cannot give you full credit for it. All right, come to the Zoom meetings if you need help, and yeah, it's been real, guys. I'll see you guys later, hopefully.